Hello everyone, welcome back to the channel and InfoSec Pandey here. So in the part 1 of the Microsoft Sentinel Interview Mastery series, we already covered the first 20 questions, starting from Sentinel fundamental architecture, data connectors, analytic rule, incidents, automation rules, playbooks, SOAR capabilities, connectors, hunting workbooks, and many real world SOC concepts that are commonly asked in interview. So we also discussed practical scenarios, how Sentinel works inside enterprise environments, and the kind of answers interviewer actually expect from SOC analysts, SIEM engineers, and cloud security professionals. So now in part 2, we are going deeper into advanced Microsoft Sentinel concept, starting from the 21st questions. So if you want to crack Microsoft Sentinel interviews for SOC analyst, Azure security engineer, SIEM engineer, or cloud security roles, this part is going to be extremely useful. And if you have not watched part 1 yet, make sure to check that out first because this video directly continue from there. So now let's continue with the question number 21. What are the different type of analytic rule in Microsoft Sentinel? So now we move to analytic rules. So this is the core of the detection in Sentinel. So this is core. All right. So there are multiple type of analytics rule available in Microsoft Sentinel. So we are going to explain when and why they are used. So the number one, we have the scheduled one. So the scheduled rules are most commonly used. They run on schedule. So they run on schedule. You can schedule it on in every 5 minute, 10 minute, 60 minute, or 6 hours, 12 hours, 1 day, 7 days. So these are the scheduled rules. You can schedule it. You write a KQL query, and if it is find something suspicious, it is going to generate an alert. So like you can define it from 5 days to every 14 days. So this is most common for the custom detections rules that we create, and it produce alert and alert convert into incidents. Number second, we have NRT rule, the near real time. So this almost instantly runs in every 1 minute, and this used when you cannot afford delay. So you can see it is running 1 minute from 1 to 5 minute latency and no look back window. So this have not any look back window, and this is for the high priority alerting, and this is very time sensitive detection. So you can set it accordingly. So for example, if a global admin role is assigned, so suppose a global admin role assigned to someone. So this is very powerful user in Azure subscription. So if somebody have the global admin access, they can change the subscription, delete the services, or create new services, create new VM. So this is very important alert, and this should be alerted in near real time. Then the third one, we have Microsoft security rules. So these come from other Microsoft tools like Defender, Intra ID, or some other Microsoft security stack like Defender for Cloud, Defender for Endpoint. So these automatically create Sentinel incidents from alert generated by other Microsoft security products. So suppose you have Defender, MDE, MDO, MDC, and you have already connected uh, these solutions with your Sentinel instance. So whenever alert generated here, it is going to trigger the same alert here. So from the Sentinel, you can monitor it by using the single pane of glass, right? So Sentinel just convert them into incidents. And then we have anomaly. So anomalies are machine learning based detections, and they find the unusual patterns. So like these are the UEBA powered, and this produce anomalies that can be promoted to alert. And the threat intel one, so uh, this matches the log with known malicious indicators and trigger alert. So this matches ingested TI indicators coming from third party or Microsoft Threat Intelligence, and then it is going to match in the log and going to generate the alert. Then the last one we have Fusion. So the Fusion one is like machine learning based, and this has a multi-stack attack correlation and cannot be edited. So keep in mind, the Fusion alerts cannot be modified or edited, cannot edited, because these are Microsoft defined machine learning based alert, so you cannot edit it. All right, question number 22. Explain the difference between scheduled and NRT analytics rule, and when would you use each? So this is very common comparison question. So the scheduled rule run in every few minutes. So this run on the configuration schedules like in every 5 minute up to 14 days. So 5 minute to 14 days. So you can schedule your rule from 5 minute to 14 days and have a look back window. So this can look back for 14 days, and it can look at the past data. And then suitable for the detection requiring historical correlations. So this can detect the patterns, trend analysis, or multi-event patterns. So this is going to support all KQL operators like join, summarize, make series, and also the look back period. So this is very common one that every like SIEM engineer use in Microsoft Sentinel environment. So suppose there is an example, brute force detection. Brute force detection. So brute force detection is very good example for a scheduled rule, because it need multiple events, right? Because you need some threshold, some user detail, computer detail, and also you need a look back period, right? While the NRT rules, the near real time rules, so they run almost instantly, like in every 1 minute, and they have latency from 1 to 5 minutes from event to alert. And the important part is there is no historical look back, so no look back. You cannot look back to the past data, no past data. All right, and no look back period, evaluate only the latest data. So that's why it is called as near real time, and this is best for high severity single event detections like ransomware indicators, privilege account changes, or critical system shutdowns. So for example, we can say admin privilege change, admin privilege changed. So this is a very good example of near real time, and you can schedule whenever the admin privilege changed. All right, so we can say scheduled alert equal to pattern based detection, while the NRT rule are instant instant alert detection. So in interview, you can say, I use NRT for critical actions and scheduled for the correlation based detections. So use NRT for alert me immediately if global admin assigned. Don't wait for 5 to 15 minutes, right? Because admin is very powerful user in Azure environment. All right, next question we have, what is alert grouping in Sentinel analytic rule, and what are its strategies? So alert grouping, this solve a very real SOC problem, because SOC receive too many alerts. So this group the alert and solve the problem. So suppose the problem is one rule generated 100 alert. So one rule generate 100 alerts, and then your SOC will be overwhelmed, right? So the solution is alert grouping. So you can group alert 1, alert 2, alert 3, alert 4, the similar alert with one incidents. So you combine multiple alert into one incident, right? So alert grouping control how multiple alert from same rule are correlated into incidents with a time window. So this group alert into a single incident. So all alert from this rule within X hour per day go into one incident. So this reduce the noise for high volume rules, right? And then group alerts by shared entities. So these are the types. So this group by account, IP, host, or URL, an alert about the same entity become one incident. So group all alerts into a single incident. So one incident regardless of entity's value. So this is going to do the bulk DDEP, right? So these are the types. So you can group your alert by various types. So what are the types? Number one, group everything into one incident. Number second, group by entity. Group by entities like IP, host, or user. And number three, keep separate. This is the one, keep separate. So for example, firewall blocking same IP 100 times. So you can group into one incident. So this is how you can reduce the noise and improve the investigation. So in interview, you can say grouping improves signal to noise ratio in SOC operations. And then we have question 24. How do you map entities in analytic rule and why it is important? So this is one of the most underrated but important concept. So let's understand what is entity first. So what is entity? So entities are things like user, IP, host, or files. So these are the entities. And what mapping does? So uh, it links alert data into these entities. All right. So for example, if alert contain username, you can map it account. And why it is important? So this help in building investigation graph, help correlation alert, and enable UEBA. So using this, you can build graph and then correlation alert, and then also you can enable UEBA because UEBA is based on the entity's behavior, right? So if you don't map your entities, what happens? So your alert become isolated and it is very hard to investigate, right? So entity mapping extract the structured object, the entities from alert data and map them in Sentinel entity type. So there are various types like account, host, IP, URL, file, process, cloud applications, mail message, mail cluster, malware, Azure resource, registry, DNS, etc. And then mapped entities become linked to entity graph, and Microsoft Sentinel's investigation map shows all incident alert and activities related to these entities. And this powers UEBA, so entity risk score aggregate across all the incidents involving the same entity. And this require a proper incident correlation and alert grouping by shared entities. So without entity mapping, your analytic rule is essential a black box, no investigation graph, no UEBA enrichment, no context, no cross alert correlation. So always map your entities. So in interview, you can say entity mapping enable correlation and investigation across incidents. Question 25. What is the query scheduling versus look back period in scheduled analytic rule and what are the optimal things? So this is a tricky but very practical questions. So two keys time parameter govern schedule rule. Number one, the run query every. So this shows how often rule run. So the frequency of the rule execution like 5 minutes to 14 days. This is a standard, and this define how quickly new threats are detected. Right. For example, your rule runs in every 5 minutes. And then we have the second parameter, look back data from the last. So how far back the KQL query look on the each runs, 5 minutes to 14 days. So this must cover the run frequency to avoid the gaps. So how much past data is going to check? For example, last 10 minutes, suppose five failure in last 10 minutes. So this is your look back. So the problem is logs are arrive late and the solution is look back should be triggered then frequency. For example, you can run your query in every 5 minutes and look back 10 to 15 minutes. So this is the key rule. Look back window is equal to or greater than frequency. So ideally 1.5 to 2x to account for log ingestion latency. For example, if you run every 5 minutes but look back only 4 minutes, a log instead of a 90-second delay will be evaluated twice or missed entirely. So use 10 to 15-minute look back with 5-minute frequency for high frequency rules. So avoid missing events. So the interview tips is you can say I always account for investigation delay while setting look backs. So the cost tips. So rules with long look back window running frequently consume significant log analytic read capacity. So you can optimize with summarized intermediate tables for expensive time series joins. So this is how you can save some cost. All right, question 26. How do you suppress alert incidents in Microsoft Sentinel to reduce the false positive noise? So this is about reducing false positive. So there are three mechanisms exist for rule suppression. Number one, query label suppression. So uh, you can fix the query, and this is the best way. So exclude known false positive condition directly in the query. So this is the best way. You can write one line query or extend your query where you can set your condition like this, where account name is not in SBC backup, health check bot, etc. for the known entities, and you can suppress it. Number second, alert suppression by rule setting. So after an alert fire, the suppression subsequent alerts from the same rule for X hours. So this prevent alert storms for the same event. So this is time based, we can say time based. And then number three, we have automation rule with close incident action. So you can set up some automation rule for auto close and auto close incident matching specific condition. You can set condition like close if computer contains test lab. For example, service account always trigger alerts, so you can exclude in query. And best practice is you can use the watch list for allow list. So you can create allow list using watch list. So for structured false positive management, you can use watch list as allow list in KQL queries. So this is more maintainable than hard coded exclusion. And then anti pattern. So never permanently suppress production rules without documenting the rationale. So suppressed detection are a compliance and audit risk, right? So in interview, you can say I prefer query label tuning over suppression for long term stability. All right, question number 27. Explain the analytics rule lifecycle from alert to incident, including the alert to incident pipeline. So this is how the detection actually works in Sentinel. So let's create the complete flow, or we can say the pipeline. So this is the step number one, query runs here, and then step number two, alert generated, and step number three, alert grouped, and then incident created. incident created, and then automation rule applied, and then playbook triggered. Playbook triggered. So this is the complete flow. So we can say step number one, the query execution part. So in the query execution part, analytic rule, the KQL runs on the scheduled against log analytics table. So tables are your data sources. So KQL runs here. And then step number two, the alert generation part. So each row written becomes on security alert entity, and the alert enrichment entity mapping, MITRE mapping, custom detection is applied here. And then step number three, alert grouped. So the incident creation logic evaluate the grouping rules. So alerts are grouped into existing open incidents and new incidents are created here. Then step number four, incidents are created. So incident appear in the security incident table with the new status and the severity from the triggered alerts. Severity could be high, medium, low, and then informational. And step number five, the automation rules applied. So Sentinel evaluate all automation rule in priority order. So you can assign honor, change, severity, run playbook, or close. So these are the action you can apply in the automation rule. Then step number six, playbook execution. So if triggered, logic app execute the enrichment response actions asynchronously. So this is how the pipeline works. So alert is a signal and incident is a case. So remember, alert is a signal and incident is a case that you need to investigate. So the real world thinking is alert multiple alert going to become one investigation case. And the interview tip is, so understand this pipeline help in troubleshooting detection issues. All right, next question is, what is the difference between automation rule and playbooks in Microsoft Sentinel? So this is a very important destinations, automation versus playbook. So these two automation mechanism have distinct purpose and capabilities. So number one, the automation rule, it's very lightweight and instant. So it's a native Microsoft Sentinel feature. Nothing needs to be enabled. So this comes with Microsoft Sentinel, no external dependencies. So it's a built-in capability. And what actions you can take, so you can assign honor. So that means you, for the specific type of alert, you can assign honor directly and change the status like new to in progress or resolve. And also you can change the severity, you can add some specific tag. Also you can call a playbook directly from here, and also you can close the incident, and this triggered by incident creation or update the incident. And what are the conditions? So 20 plus attributes like entity type, alert name, severity, tactic, product you can include, and this execute synchronously with seconds. So we can say that this is built inside Sentinel, built inside Sentinel. This is pretty fast, and this have some limited actions. And the important part is you cannot customize the actions, no custom actions. And then number two, playbook. These are very powerful and flexible. So basically, these are the logic apps, the Azure logic app. So it's a separate service and the full workflow orchestration with 1,000 plus connectors. So they have connectors available for various type of solutions and applications, and you can configure the connectors. And then you can call the external APIs, query, threat intel, send a team message, notifications, email notifications, block the IP in firewall, disable user account, or reset the password, notifications, or isolation the endpoint. So this is your full fledged SOAR capability, I would say. And this triggered by when the incident trigger, alert trigger, or entity trigger, and then execute asynchronously. And you can take it can take minutes or hours. So this execute asynchronously, and it can take minutes to hours. So we can say this is built using Logic App. Logic App is a separate service that you need to uh, pay as you go. And then this is very powerful. Every type of actions are possible here with supports by application or API. So this is very powerful, and this can integrate the external system. So external system integration is possible. Automations rule equal to quick action and Logic App full automation workflow. Full automation workflow. So in interview, you can say, I use automation rule for triage and playbooks for enrichment and response. All right, next question we have, design a playbook to automatically enrich an incident with virus total threat intelligence. So a virus total enrichment playbook architecture looks like this. You can trigger, so trigger the Microsoft Sentinel when an alert created or updated. So trigger when incident created or updated, and then you can parse the entities, parse entities. So you will get all the details like IP, URL, and has here. And then from here you can do the HTTP action. So HTTP action include the virus total API call. So it is going to call the virus total API and going to fetch the details with the API headers, and then parse the response, and then it is going to provide the detail directly in your comment or in the report. So this is how the architecture looks like. So enrichment incident with threat intel is very powerful, and it triggers when Microsoft Sentinel or incident created, then parse the entities IP URL has, and then HTTP action. So this is going to call the virus total API by using the get command, and then parse the response by extracting the malicious count and all. So this is the condition we can use, the reputation score, community votes, and then condition. If malicious detection is greater than threshold, like 5, then it is going to provide the details. If the true branch, then you can set another condition here, true and false. So this is going to tag like confirmed malicious, or clean. So if malicious, you can increase the severity. If clean, you can add the comment, add comment, or increase the severity of the alert. So this saves analyst time. And in the interview, you can say this automates enrichment and speed up the incident triage. So the modern approaches use the native virus total connector in Logic App. No custom HTTP action is needed currently for built-in authentication and schema handling. So that means the Logic App supports the virus total connector. So we can configure the connector directly in the Sentinel itself. Question number 30. What are the three playbooks trigger type in Microsoft Sentinel, and when would you use each? So there are three types. Number one, incident trigger. Number two, alert trigger. And number three, entity trigger. So incident trigger runs when the incident is created. So this fires when the Sentinel incident is created or updated, and this has full access to incident metadata, all linked alert, and all type of mapped entities. And this is most common for enrichment and response. And then the alert trigger. So this fires when an individual alert is generated, and that means it runs for each alert before incident grouping. So this is useful for immediate or per alert actions, especially when you want to act on every alert regardless of the incident grouping. And then uh, entity trigger. So this manually run against the specific entities like user, host, IP from the entity page. So this is more granular and manual used by analyst. So it is used on the on demand investigation playbook like run OSINT on this IP, invoke by analyst, not by automation rules. So we can say incident based like case label, alert based event label, and entity based trigger is object label. So in interview, you can say, I prefer incident trigger for most automation to maintain full context. So the best practice is prefer incident trigger for most SOAR workflow, and alert trigger loses context once alert are grouped, and entity trigger is powerful for analyst initiate enrichment. All right, question number 31. How do you handle playbook error and ensure resilience in Logic App? So, the production playbook resilience strategies are number one, you can configure each action's run condition. So, that means you can set the run after. So, run after is a feature that you can configure after each block. So, this setting can help you on actions to handle failed, escaped, timeout, preceding actions. And number two, scope actions with error handling. So you can wrap the risky action in a scope, and you can add a parallel branch like this. If scope failed, branch to the log error. And then number three, the retry policy. You can configure the exponential back of retries on the HTTP API actions. So this is especially for the rate limiting external APIs. Number four, you can use the terminate action gracefully. So on unrecovered error, you can terminate the run with status failed and log detail to Sentinel incident comment. Number five, Azure monitor alert on logic app failure. So you can alert the SOC team when playbooks are failing. So this is very important for playbook health monitoring. Playbook health monitoring. And the observability. So observability is like configure logic app diagnostic setting to send history to your Sentinel workspace. So this you can do using KQL query over playbook execution failure. Question 32. What is proactive threat hunting and how does Microsoft Sentinel support it? So now we move into one of the most important skill in cybersecurity, threat hunting. So the proactive threat hunting is a hypothesis driven investigation to find threat that have bypassed the automated detection, not waiting for the alert, but actively searching for TTPs, the tactic, technique, and procedures. So hunting equal to like looking for TTPs, the tactic, technique, and procedures. So Sentinel hunting capabilities are like hunting query, live stream, bookmarks, and notebook. So what happens normally in SOC? Alert comes, and then you investigate, right? But in threat hunting, you don't wait for the alert. Don't wait for the alert. You actively search and find the threat. So we can say threat hunting is hypothesis driven investigation. For example, instead of waiting the alert, you ask, what if someone is using a stolen credential? So the options available is like hunting query. So you can use the saved KQL query in the hunting blade, tagged with MITRE attack, with matrix showing past result count, live streaming, like subscribe to a hunting query and receive real time results as they match. So this is near real time hunting without creating an analytic rule. So this is alternative of without running the analytic query, you can run the live stream. Then bookmark, so you can save the interesting raw data using investigation for later review and add them as the evidence to incident. Then we have also notebook. So Jupyter Notebook integrated with MSTI library for advanced threat hunting with machine learning visualization. So if you are good with Python and Jupyter Notebook, you can utilize this feature. Interview tips, you can mention like threat hunting help detect threat that bypass traditional detection rules. Question 33, write a KQL hunting query to detect potential lateral movement using pass the hash technique. So this is the real attacker technique. And what is lateral movement? So suppose this is attacker, so he compromised one system and entering one system, then from here he try to move across network. So this is called the lateral movement. Lateral movement. All right. And what is the pass the hash? So pass the hash is something like instead of password attacker use the hash to authenticate. So they use hash to authenticate. So this is called pass the hash. And what are the detection logic? So you can use the NTLM authentication, multiple system accessed, and then same user across many hosts. So logic is NTLM authentication and multiple system accessed, and then same user across many host, because a single user is trying to literally move on other network or other like computers, right? So we can say if one account suddenly access multiple machines, so that's very suspicious. So normal user don't log in into 10 system in 1 hour, right? So let's write the query here. So we can start with the security event and then event ID 4624, which mean success, logon success, and then logon type 3, which mean the network logon type, and where the authentication package name NTLM. So this is the important condition, right? And then workstation name doesn't equal to blank, and then the target user does not end with dollar sign. So this is a machine account, right? So we can exclude it to reduce the false detection, and then extend the log on hour equal to hour per day and time generated, and then we can summarize the result by computers. So D count computer means this is going to count the computer, and then NTLM logon count. Then computer, we are going to make a set of the computer by target user. Target user is the user who logged in, and then IP address, and then also we can bin it in every 1 hour. So this is going to find how many time user logged in on the computers in 1 hour. So there is another condition we can put to reduce the false positive. So target computer is like greater than 3. So this is going to assess many systems like lateral movement. So we have given it 3, you can give it 4, 5, 6, whatever you want. Then order by target computer descending. So this is how we can write the KQL query to detect the lateral movement. So the context is you can combine with event ID 4776. So that's the NTLM validation failure. And then event ID 4748 for explicit credential use for a full lateral movement picture. Question number 34. What are Jupyter notebooks in Microsoft Sentinel? And what is MSTI CPY? So this is advanced but very impressive if you are explain it well. So Sentinel integrate with Azure Machine Learning Notebooks provide Jupyter Notebook as an advanced hunting environment. And then the MSTI the Microsoft Threat Intelligence Python library. It's an open source Python library purpose built for sentinel hunting like data loading, enrichment, visualization, machine learning, anomaly detection, IOC lookup like virus total, MDTI, abuse DB, timeline visualization, and network graph. So notebook can run long running queries and that put time out in the portal. And this also combine the Sentinel data with external threat feed, GeoIP, who is in Python. So if you're a Python lover, you must run this. And then reproducible hunting. So notebooks are documented playbooks for human analyst. So what are notebooks? So notebooks are interactive environment. So they are the interactive environment for running queries. So you can run the queries and visualize the data using various chart, graph, etc. Visualize data, and then you can do the analysis. And what is MSTICPY? So this is a Python library, .py library for security analyst. So this is specifically created for security. So what you can do the timeline analysis. So use case, timeline analysis, and IP enrichment and TI correlation, graph analysis. For example, you can analyze the attack chain visually using this Jupyter Notebook and this Python library. So how you can get started? You can getting started by notebook template with MSTI CPY, which is pre-configured for workspace connection, and you can launch it from the threat management and notebook. So in interview, you can say notebooks enable deep investigation beyond standard dashboards. All right, question number 35. What are the main data connector type in Microsoft Sentinel? So Microsoft Sentinel data connectors fall into three categories. Number one, first party, the Microsoft first party data connectors. So these are the native data connectors like Intra ID or Microsoft Defender XDR or Microsoft Cloud or Office 365. So these are the inbuilt data connectors. And now we can say it is unified platform, right? So these are the inbuilt data connectors provided by Microsoft. Then the number second, we have Ceph based and syslog based data connectors. So these are the Linux syslog forwarding with AMA agent. So AMA agent is the Azure monitoring agent, which we are going to deploy on the each machine or legacy MMA. So this is depreciated now. It's not being used. And this is common for network devices like Palo Alto, Fortinet, Cisco ASA. So suppose this is your firewall device and you want to integrate it with Microsoft Sentinel. So you can create a machine here, which is syslog collector, and from firewall you can configure the data forwarding to this machine using syslog port, and then from here you can deploy a AMA agent, and this AMA agent going to send the data directly to Microsoft Sentinel. So this is how you can do the forwarding of the data for your networking device like firewall and all. And then REST API based uh, connectors. So number three, REST API based connector. So you can create your custom data connector using DCR rule, the data collection rules, and AMA. So this is a Microsoft modern approach which is going to replace the MMA. And the DCR rule, like data collection rule, can be created to separate the various data sources, create tables, indexer and all. So DCR rules are very important. And then we have some Azure Event Hub. So this is high throughput streaming from Kafka and compatible systems, and some partner connectors like pre-built connectors for CrowdStrike, Okta, Zscaler, AWS. So these are available in the marketplace. And some custom REST API based connectors like direct log ingestion via log ingestion API, which is formerly known as HTTP data collector. So these are the data connectors that we can utilize in Microsoft Sentinel. Next question we have, explain the difference between AMA and legacy MMA. So Microsoft is migrating from MMA to AMA, and currently MMA is no longer in use, and you must know both for interviews. So MMA is legacy based. So for Windows, Linux agent using direct agent or OMS gateway. So you can configure in workspace setting and then the single destination workspace. So this is being retired in August 2024 and this is 2026. So this is already depreciated. So MMA is no longer in use. So we need to focus on the AMA side. So this is the modern one, and this uses the data collection rule that's called DCR. So if you are working on the Sentinel, you must understand the DCR rules. So this use the DCR rule for configuration, and the multiple workspace destination can be utilized here. And this also support the data filtering at the agent level. So this is going to reduce the ingestion cost. So using, so suppose you have 5 machine here, you can install the AMA agent here and send data to Microsoft Sentinel directly. And in the Sentinel side, you can create the DCR rule to do more filtering of the data. So this is managed by a Azure policy at a scale and supports both Windows Security Event and syslog Ceph. And the data collection rules. So these are the Azure resources defining. So DCR is Azure resource defining which data we need to collect, transformation you can apply, and this is very simple. The KQL based uh, filtering you can apply in the DCR, and which workspace you want to send it. So migration urgency. So if you have not migrated the MMA to AMA, you can migrate it because currently the AMA is only being utilized. Question 37. How does the Microsoft Defender XDR integration with Sentinel works in unified SOC platform? So Microsoft has recently introduced a unified SOC platform that integrates the Sentinel directly into Microsoft Defender portal. So earlier Microsoft XDR has MD, MDO, TI, everything, and now they integrated the Sentinel in the same portal. So now it is known as unified platform. So Microsoft Defender XDR connector is going to synchronize the Defender XDR incident, which is going to combine the endpoint, identity, email, cloud, and bidirectionally with Microsoft Sentinel incident. And the advanced hunting query in Defender XDR now available in Microsoft Sentinel table and vice versa. So you can utilize both in Microsoft Sentinel. And then SIEM integration path. So organizations can have Sentinel as their analytics layer while working incident in the Defender portal's unified queue. And the entity page are shared. So clicking on the user in Sentinel shows Defender signal and vice versa. So you can think about it. It is very strong now, right? And the important thing is when the XDR connector is enabled, duplicate incident can occur. So if you also have like individual product connectors like Defender for endpoint, Defender for identity, so you can disable the legacy connectors after enabling the XDR. Question 38. What is the incident life cycle in Microsoft Sentinel? So this is the Microsoft Sentinel incident status and life cycle, we can say. So Microsoft Sentinel incident have new, active, and closed status. And new is when the incident created and not yet assigned or triaged to any analyst. And then active one, so analyst is actively investigating and the honor is already assigned. And the closed one, so incident is closed and completed and the reason is required. So reason you can fill true positive, benign positive, false positive, and undetermined. So true positive is like suspicious activity confirmed, and the benign is suspicious but expected activities, and the false is incorrect alert logic. So incidents are stored in the security incident table. So if you log in on the Sentinel, you can run the security incident and you will see all the incident listed in the result. And the alerts are stored in security alert table. So these two table you can note down. And if you're running the query on the Sentinel, you can run these tables. And the closing reason feed into MTTD, MTTR, KPIs measurable in workbooks. Question 39. What is the investigation graph in Microsoft Sentinel and how does it aid incident investigation? So, the investigation graph is an interactive visual representation of an incident. So, this is shows the entities like this. This is how the graph looks like. So, this shows the users like this and the IP detail 8.8.8.8, and then the URL www.test.com, and the file has test.exe, and this is the incident number 101 or something. So all entities are linked to incident like user, IP, host, file, URL, everything. So this is your incident number and everything is linked here, right? And the relationship between entities like user logged into host, host communicated with the IP. So all those detail by clicking here you can get, and the timeline of the related alert and activities over a configurable time window. And then entity expansion. So click on any entity to reveal the related alert, sign in, or activities from the other data sources. So if you click here, it will provide you more details. So the graph queries the behavior analytics, the identity info, and entity specific table to enrich the each node. So these are the nodes. So the investigation tip, the investigation graph explore feature in particularly powerful for mapping blast radius. So you can understand how many other systems has this compromised account touched or file touched or this URL communicated. All right, next question we have. How do you track and improve SOC metrics like MTTD, MTTR using Microsoft Sentinel? So MTTD, mean time to detect, and MTTR, mean time to respond, are the key SOC KPIs. And the KPI means this is how we are going to measure or govern the SOC. And the security incidents table stores the created time, first activity time, last modified time, closed time, and status. So these are the tables or data tables that are going to help in calculating the MTTD and MTTR. So this is your created time, created time. This is your first activity time, activity time, and this is the closed time, closed time. Okay. So what is MTTD? So MTTD means created time plus first activity time. So this is your MTTD, mean time to detect. And this is how long before we detect the threat. And MTTR, so this is closed time to created time. This is closed time to created time. And this is the MTTR, mean time to resolve. And this is how long to resolve after detection. So the KQL example here is security incident table where the status is closed and extend the MTTD where the date time difference hour, created time, first activity time, and then extend it MTTR detection difference hour, close time, created time, and then summarize average by MTTD, average MTTR, count by severity, bin created, etc. Question number 41. What are the Microsoft Sentinel workbooks and what are the most important built in workbooks? So, workbooks are interactive dashboards. So, workbooks are the dashboards. So, Microsoft Sentinel have unique naming in their solution. So, they call dashboard as workbook. And this is built on the Azure Monitor workbooks, combine KQL queries with rich visualization like chart, grade, map, tiles. So workbooks are purely built on the KQL. And what are the key built-in workbooks? So some of the workbooks available in Microsoft Sentinel is built-in Azure Activity. So this provide the Azure control plane, changes, resource creation, deletion activities, Microsoft Intra sign-in. So this provide the complete pattern, risky sign-in, geographic anomalies and all, security operation efficiency, so MTTD, MTTR, analyst workload, incident trends, and zero trust one. So this is the good one. This is my favorite one. So this provide the compliance dashboard for US governance or government, zero trust framework, and then investigation insight for entity centric deep dive workbook, and then SOC IR, so incident response tracking for evidence gathering. Next question we have: how do you create a parameterized workbook in Microsoft Sentinel for executive reporting? So, a parameterized workbook use dynamic input for filter data. So, you can add, so suppose this is a workbook, so you can add a time picker here like 30 days, 60 days, or 90 days, whatever time you want. So, time range picker like a standard parameter for controlling query look back, 7, 30, 90 days, and then drop down parameter. So drop down parameter like pulling the value from KQL, like unique subscription ID. So from here you can add a drop down one, subscription ID, severity, owner name, and filter all the workbook titles. And then text parameterized. So this is pre text input for user and IP search. So you can add another one which is required to provide the user detail or IP. So suppose 8.8.8, then it is going to provide all the visualization. And executive report essential. So total incident by severity, top 5 incident type, MITRE tactic breakdown, MTTD, MTTR, trend chart, data ingestion volume and cost trending, mean analyst workload incident per analyst per day. So this could be a good executive, or we can say the CISO report. And the sharing part, so workbook can be pinned to Azure dashboard or shared via URL or exported as a PDF using browser print. So no separate license required for printing and sharing. Next question we have: design a cost optimized Microsoft Sentinel architecture for 50 TB per day enterprise ingestion. So the cost optimization strategy for high volume Sentinel deployment. So there are commitment tiers that you can choose. So at 50 TB per day, 50 TB per day commitment tiers cost would be like 40% less than pay as you go model. So you can calculate the break, even, and commit. So number two, the tier data routing. So the high fidelity security event, you can send it to analytic tier. So this provide the full KQL and alerting capability. So high severity security data you can send to analytic tier. So analytic tier is basically your live data where you can search, hunt, or do the alerting part. And then the proxy, NetFlow, verbose, firewall. So these you can send in basic tier. So less security data you can send to basic tier. In the basic tier you cannot do the alerting, but the query and uh, hunting you can do. Then the compliance archive, so these are the auxiliary tier, so these are very cheapest or long term retention. So I would say this is a cold bucket or frozen bucket. type of data. Then also the agent label filtering we can do. So AMA-DCR transformation to drop low value field before ingestion, like dropping the successful health check logs, right? And then ingestion transformation using DCR. So you can parse and drop the irrelevant rows server side before billing. And then the ADX part. So Azure Data Explorer integration. So this is a kind of data lake. So you can offboard historical hunting query for cheaper ADX storage with continuous export from Sentinel. So you can continuously export data to data lake. Question 44. How does Microsoft Sentinel integrate with Microsoft Defender Threat Intelligence? So Microsoft Defender Threat Intelligence integrate provide the enriched threat context like intelligence connector. So there is a inbuilt connectors available in Microsoft Sentinel for TI. So you can ingest MTTI indicator using IP, domain, has, URL, CVs into threat intelligence indicator table. So this is the table where you can do the query. And then threat intelligence matching analytic rule. So auto matches ingested IOCs against log data table like sign in log, common security log, Azure activity log. So there will be a correlation between this and multiple data sources. And then enrich incidents with MDTI context. So playbook can call MDTI APIs to get actor attribution, infrastructure profile, and vulnerability context. And then MDTI article in Microsoft Sentinel. So this is a curated threat intelligence article surface relevant indicator linked to the active incident. So premium versus standard. So there are two type of license available. So MDTI standard is included, and premium MDTI add deeper actor tracking, infrastructure analysis, CV intelligence, STIX taxi feed from third party, also ingest into threat intelligence indicator table. So you can choose wisely. All right, the next question we have: how would you implement a zero trust SOC architecture using Microsoft Sentinel? So, zero trust SOC principle in Microsoft Sentinel architecture can be like never trust beyond telemetry. So, you can validate the data integrity, use private endpoint for agent communication to prevent MITM log tampering. Number two, the least privilege workspace access. So, the resource centric RBAC you can set up like table level reader role using resource group scope. So analyst only query log from assets they own. Then private link for Sentinel supports all agent ingestion through Azure private endpoint and no public internet exposure. Then customer managed key is the CMK. So you can use the CMK to encrypt workspace data with own Azure key vault keys for full data sovereignty. And then the conditional access for portal access. So require MFA plus compliant device to access the Sentinel portal, and then the immutable workspace like enable workspace immutability to prevent log deletion like anti-tamper compliance. So these are the controls we can implement to follow the zero trust model in Microsoft Sentinel.